So we have two more examples here. I am dividing 3x squared minus 2x plus 1. Notice I'm trying to keep all my columns very clear, and then divide that by x minus 3, and that goes out in front. In my first d divide step, I'm going to take my first term of my polynomial divided by the first term. I can't take the whole polynomial divided by the whole polynomial, that's just too hard, so I'm just going to take the first divided by the first. So 3 divided by 1 is 3, x squared divided by x is x. That 3x goes in the quotient above the division sign, above the 2x, because 3x is a like term with 2x, and we want everything in that column to be like terms. M, multiply. I'm taking the 3x and I'm multiplying it to both terms of the divisor. 3x times x is 3x squared. 3x times negative 3 is negative 9x. And now I'm going to erase those little lines. The C step says change both signs. So I'm going to change my positive 3x to a negative and my negative 9x to a positive. The 3x squared minus 3x adds to 0. That's the whole point. Negative 2x plus 9x is 7x. And that was my C step. So the R step says to repeat. So I'm dropping the 1 and I'm going back to my D step divide. I take the first term 7x and divide it by the first term x in the denominator. If you want to use some scratch paper to take 7x divided by x and get 7. Notice it's a number, which is perfect. It should go in the next column over as the number column. That's exactly what I was hoping to have happen anyway. So 7 times x is 7x. 7 times 3 is negative 21. Now I'm going to go back and erase those. The C step says to change both signs. So I'm going to change the sign of the positive 7x to negative, and from the negative 21 to be a positive 21. Change both signs. So 7x minus 7x adds to 0. 1 plus 21 adds to 22. Now I can't all drop and repeat because there's nothing else to drop. So that tells me about this 22, especially because it's a number, is a remainder. So I'm going to add the 22 over the original divisor, which is x minus 3. This is my answer, 3x plus 7 plus 22 over x minus 3. Next, I'm going to divide x cubed plus 1 over x plus 1. Now this one's different than all of the rest because we have x cubed. Remember how I kept telling you how important the columns were? If I do x cubed plus 1, I'm missing a couple of columns. I'm missing the x squared column and I'm missing the x column. If I proceeded to do it like this, now I honestly don't want you guys to write this for a moment because I'm going to erase this, okay? So just watch until I tell you to write, otherwise you'll end up erasing. If I proceeded like this, and I divided x cubed divided by the first term x, and I get x squared. Where should I put x squared? Like I can't put it here because that would make the x squared over a number, and that doesn't make sense. So if you accidentally did it like this, then you would right away notice that there's a problem. So going back to the original setup, instead of writing the plus 1 here, what I'm going to do is I'm going to add a 0 for the x squared column, because no x squareds is the same thing as not having any at all. And I'm also going to put a plus 0x, and then I can put my number 1. The exponents on my numerator have to go down decreasingly in order. So x to the 3, then the next column has to be x to the 2, then the next column has to be x, and then the next column has to be a number. So by putting in these zeros there, I have made my columns every single column that I'll need from x cubed all the way down to the number column. So when I take the first divided by the first, I'm getting x squared. Now I have somewhere to put that x squared. The M step says to take the x squared and distribute it. So x squared times x is x cubed. X squared times 1 is 1x squared. The C step says to change both signs. The x cubed adds to 0. 0x squared minus 1x squared is negative 1x squared. R says to repeat. I'm going to drop my 0x and repeat. The D step says divide. I'm going to take the first term, which happens to be negative 1x squared, and divide it by the first term in the divisor, which happens to be x. Negative 1x squared divided by x is negative 1x. One of the x's divide out, and you'll still left with 1x. So negative 1x should go in the next column over, which is perfect. That's right above the other x terms. Now the M step says to multiply, so I'm going to multiply this to both. Negative 1x times x is negative 1x squared. Negative 1x times 1 is negative 1x. I'm going to erase these multiply lines. And then in my red step, I'm going to change both signs. So I'm changing this negative 1x squared to a positive, this negative 1x to a positive. The negative 1x squared adds to 0, and 0x plus 1x is 1x. The R step says to repeat, so I'm going to drop the next number and repeat. And going back to the purple D step, I'm taking the first term divided by the first term, so I have 1x divided by x. That leaves me with just 1, which is a number, which is perfect because I have the number column next that needs to, that the number is going to be above. So in the M step, I'm going to take 1 and multiply it to both terms. So 1 times x is 1x. 1 times 1 is plus 1. Now I'm going to erase these multiply signs. And C, change both signs. So in the blue polynomial, I'm going to change that to a negative 1x and a negative 1. When I add the negative 1x minus 1x adds to 0, that's kind of the whole point. But what accidentally also happened is 1 minus 1 is also 0. That tells me that I have a 0 remainder. Remember when we had 32 divided by 8 in the original problem? I said that was 4, and this would had no remainder. Well, there's no remainder, it's just like the answer, right? So because the remainder is 0 here in polynomials, the answer is just x squared minus 1x plus 1. That's it. There's no plus remainder over divisor because the remainder is 0. And writing plus 0 over x plus 1 is redundant. No one writes plus 0, right? So we can erase that and just leave my answer as is. And this concludes our lesson on dividing polynomials.